Solutions for Math 1 and 12. These first two problems, you're asked to simplify these these compositions of inverse trig functions and trig functions. And the basic idea on these problems is the method will always be the same. We'll start out by letting maybe t be equal to the inverse trig function. So in this case, it's arctangent of x. And the reason you do that is that allows this to simplify to just the sine of t. Right? If arctangent of x is this thing t, then this simplifies to just sine of t. So if t equals the arctangent of x, I can take the tangent of both sides of the equation to get that the tangent of t equals x, which I'm going to write as x over 1. The reason I'm going to write it as x over 1 is because that way when I draw this kind of arbitrary triangle and choose to put t here, and remember that SOHCAHTOA tells me that the tangent of an angle t gives me the ratio of the side opposite that angle to the side adjacent that angle, I get that this is an x and this is a 1. And if this is x and this is a 1, you can use Pythagorean theorem to figure out that this is 1 plus x squared. This squared plus this squared must be equal to this squared. And if you have this triangle right here, you can stare at this triangle and figure out the sine of t. The sine of t, well, let's see, SOHCAHTOA, sine is opposite over hypotenuse. So the sine of t would be x divided by square root of 1 plus x squared. That's your answer. And then for the second problem here, it's actually pretty similar because you do the same substitution, right? We can let, I guess over here, we can use the same picture. Use same substitution. So I'm still going to let t be equal to the arctangent of x. That means that secant of t is what I'm trying to figure out over here. Well, if t is the arctangent of x, I can say that tangent of t is x over 1, so my triangle looks like this. If I'm trying to figure out secant of t, I have to recognize that secant is the reciprocal of cosine. And cosine would be adjacent over hypotenuse, so this would be 1 over the cosine, which is 1 over the square root of 1 plus x squared. This down here is the cosine, the secant is the reciprocal of that, so it's equal to the square root of 1 plus x squared. So that right there would be your answer. For the next problem, or problems I guess, this is a law of sines problem. You are told that angle A is 30 degrees, little a is 1, and little b is root 3, and asked to find a solution for b between 0 and 90 degrees. So what you have to know is that the sine of A divided by A is equal to the sine of B divided by B. And since A is given to me to be 30 degrees, I know that the sine of 30 degrees divided by little a, which is just 1, is equal to the sine of capital B, which I don't know, divided by the square root of 3. But wait a minute, the sine of 30, I got that memorized off my unit circle, that's 1/2. So 1/2 must be equal to the sine of B divided by the square root of 3. Yep, that's true. And if I multiply both sides by the square root of 3, I'd get that the sine of B will be equal to root 3 over 2. So therefore, B would be equal to, well, there's several different angles whose sine is equal to root 3 over 2. 60 degrees is one such angle. But that's not the only one. That's just the only one that's between 0 and 90 degrees. So this would be the answer here. But down here, I could say, I don't know, the sine of 120 degrees also equals root 3 over 2. So B could equal 120 degrees, which I guess I could write as 4 pi over 3. No, I couldn't. 2 pi over 3 if I had a thing for radians. I don't care that you write it both ways. As long as you can get one or the other, we're good. And that's it. You don't use those to find other angles or anything. That's all I want you to get, is that when you're using the law of sines, there's this ambiguous case where you can have multiple solutions. That's it. This last problem here, how far is it from the ranger's tower to the fire? This is just another application of law of sines. The difference here is you're given two angles and asked to find a distance. So let's see, if I call this distance maybe x, I can use the law of sines to say that the sine of 34 degrees divided by 150 must be equal to the sine of 97 degrees divided by x. So if I multiply my x to the top and then multiply the 150 to the top and divide the sine of 34 to the bottom, I'd get x is equal to 150 sine of 97 degrees divided by the sine of 34 degrees. And since those aren't values off the unit circle that you have memorized, that's a perfectly good answer, just like that. So that's the answer to this problem, and I guess that's the end of this quiz.